Hey, what's up, class? We're going to continue to talk about communication waves. This is a follow-up to yesterday's lab where we were looking at fiber optic cabling. One of the biggest things about fiber optic cabling is total internal reflection, the angle at which all the incident light reflects at an interface, with no refracted light passing through to the new medium. Fiber optic cables connect the world by making communication possible. They're in our homes, workplaces, hospitals, and even at the bottom of the sea. Light can be transmitted long distances through optical fibers. Complex information like words, sounds, and images must be encoded to be sent as light. In modern communications, such as the internet, cable TV, and telephone communications, information is sent via signals in laser light through clear cables called optical fibers, which are also known as fiber optics. Optical means it has to do with light wave. Optical fibers used for communications are made of glass, and you should handle the fibers carefully because if bent too far, they'll break. Our focus question for this segment: what are some design constraints in fiber optic communications? Optical fibers carry information for very long distances by using total internal reflection. The information is encoded as light. We'll learn more later about how this code is created and used. Light waves travel very fast. Information sent from New York by fiber optics could reach Australia in less than 1/10 of a second. Engineers who design fiber optic applications have to work with the constraint of the ability of the fiber to transmit messages. A bad design might cause loss to total internal reflection, with the result that the light refracts out of the sides of the cable instead of carrying the message through. Based on yesterday's lab, you were able to see the smaller diameter resulted in the loss of signal. This is important to have fiber that maintains total internal reflection, because if the light did not reflect, the message would be lost. Installers need to be certain that cables aren't bent too far. That means going around a corner is impossible. The installer cannot bend the cable too far to go around a corner, so one would have to go through a wall, a ceiling, or even underground. This brings us to today's lesson: data transmission. Consider data transmission as patterns of light. Extremely complex information, like high definition video, being shared online must be sent as light waves through a cable. This information must be encoded to be sent as patterns of light. One model of how information can be encoded is Morse code. Even though actual internet data, cellular phone, and TV signals are not sent by Morse code, but Morse code serves as a model that we could use to understand how information is encoded and sent through optical fibers as light waves. In this discussion board, you will be required to record a video using a flashlight, either handheld or from your phone, or by flicking on and off your lights, and challenge each other to send a one-word message using Morse code. Each person is required to create a post using Morse code, and you'll also be required to reply to just one person. So you create one word and you have to reply to one word. That means you'll need to check back to this discussion board today and tomorrow. The sooner you get your video posted and the sooner you're able to reply, the sooner the assignment is over for you. If you post just the video, that's half credit. To get full credit, you need to reply to a person too. Once the person replies to the Morse code message, it is up to the coder to tell the person if he or she is incorrect or correct. For example, yes, you are correct, or no, you are not correct. Do not give away the Morse code until the person deciphers the word. Remember that this is school, So that means no inappropriate words or slang terminology. If you have any questions, message me through Canvas. I hope you're all doing well. Peace out.